Hi, everyone. My name is Willie Turney, and I am on the Google Cloud Community team. I've been counting down the minutes, days, and hours for this session. We've got some great content for you all. Without further ado, before we begin, please use the chat on the right-hand side of the screen. If we don't get to them at the beginning, we will get to them at the end, and we will continue the conversation in the Google Cloud Community. Without further ado, I will pass it off to Sarah, Olga, and Alex.
Great. Good to see everyone. Thanks for joining us this morning. I am Sarah Weldon. I am the lead product manager for Google Cloud Translation at AI. And this morning we are going to be talking about more responsive translation at scale with generative AI. Two other speakers who are joining me who will speak later on is Alex and Olga. They'll also introduce themselves. They both are at Smartling. One of our partners and integration softwares that you can use our Google Translation with. Today, just the general agenda, I'll go through our general introduction, give an overview of translation AI, our recent advancements that we launched at Google Cloud Next, and then they'll go into their case study and we can take some Q&A at the end. Any questions that we don't get to, we will answer in the cloud community after the session. So why are we here talking about translation today? It's a lot of companies and organizations and people have needs to be able to offer content to their customers, to their employees in their own languages. It helps with access to information and it helps people with collaboration. The global supply of translators for doing human level translation and interpretation is much smaller than the amount of content that we have in the world. For the total potential translated content just for the top 50 languages would require about 2 billion translators to be able to serve. And your audiences are global and increasingly digitally savvy. So in order to help you scale and help you reach more languages, offerings like Google Translate APIs and the newest and best models that come out every year have a pre-built API that allows you to integrate with features to help you scale with minimal overhead for your company. And regardless of what content you're editing, it shows up in many different formats. And so we understand at Google that it's really important that we work to serve keeping that translation handled in the context and in the formatting that it originated in, so that it can be kept in the same level of information as what you're reviewing it in. Whether it is document translation for market research, multimedia translation with video and audio, text content translation on websites and forums, or customer service with things like telephony, phone and customer agents. So all of these are relevant translation use cases. And part of the great thing about having APIs is that you can integrate with many different systems that support these formats. And our APIs also support some of these formats and use cases directly. But doing it well at scale also requires kind of a lot of nuance, and it can be very challenging. That's where partners can come in and help with bridging any of the gaps that aren't either filled with your own company information or with the APIs and the models themselves. So translating is easy. You can just do it with Google Translate. But once you get into it, it can have a lot of nuance in order to keep it improving and changing and adjusting with your content. So one of the key things that a lot of companies do is customization. In order to be able to do customization and make these models more flexible to your particular use case and continue to drive up the quality, you often need to have some of your own data in place, whether it be in glossary form or full sentences for fine tuning. And that requires clean training data. The other thing to keep in mind is meaning when you're doing translations is context dependent. And I'm not just referring to the format of the context, but also what's the other surrounding information in that context. So the full sentence length, multi-sentences with paragraph level information, or even getting into turn-based discussions with people, the meaning of that, a lot of that interpretation depends on the rest of the information provided. And then scale, human projects takes weeks and a lot of money in order to be able to do. And so the value that machine learning and machine translation brings to play is being able to, in some cases, combine, and in some cases just move without it, to be able to reach more people. But a lot of this can require kind of a lot of learning and flexibility and some risk taking as you're learning how to roll these things out to provide more information to users and try and keep progressing more on accuracy, quality, and fluency so it resonates with them. So automatic metrics often come into play with that. They can help provide real-time or like rapid feedback on how your quality is changing over time and if it's staying relevant to your use cases, when you should retrain models, or when you need to do some sort of adaptive path to make it modified. But often it gets paired with human evaluations. It can be flexible to capture a lot of the things that automatic metrics don't catch. But it is high cost, and it takes longer for getting those evaluations back. So that's where translation AI and some of the cloud providers can step in to help by integrating with our APIs and other elements of the Vertex AI platform. You're able to reach more of these tools that kind of lend themselves well to scaling up and getting more information about like what tooling you can do with your data sets. So our mission is to organize the world's information and make it universally accessible and useful at Google. And for my team in particular, that means making it available in more languages, making your content available in more languages, but also making it more flexible as the technology progresses, making it more flexible with context. So it's often a partnership between the customer's information and Google's machine learning models and APIs to make them work well together so that it's customizing sufficiently for your particular implementation. And so that is why we offer Vertex, all these things in the Vertex AI ecosystem. If you think about the Vertex AI platform, it is our whole set of tools, building everything from Model Garden to Model Builder to Agent Builder. So it's all focused around machine learning, the capabilities that you need in order to be able to work with models and work with data and be able to run programming with them. Model Garden is basically your catalog where you can come in and take a look at all of the models that are out there in the ecosystem, whether they be foundational, general purpose, large language models, open source or proprietary, or whether they be Google's dedicated out-of-the-box APIs. Those are also discoverable through the Model Garden catalog just by doing searches within there. Once you select a model, depending on what type of work you're looking at doing, you might be looking at open source, you might be looking at pre-built, but then you need to know what to do with it, how to deploy it, working with the training and distillation and making the data function well for your use case. And that's what the model builder part of the platform is for. It also allows you to do experimentation with prompts, with serving, tuning, and whether that be parameter efficient tuning or full fine tuning. So that's what the model builder ecosystem fits into. In our case, the agent builder piece is where my team focuses. This is the out of the box and custom agents with our APIs. So we have a set of models. We are basically doing API design and curation specifically for a task. In this case, it is language translation. But the nice thing about coming to Google Cloud and Vertex AI is within your company, if you have a couple of different teams, you can think about these different layers of the platform and how you're building out your overall localization strategy. So Vertex AI helps enterprises build transformative AI experiences with enterprise-ready AI. And when we're talking about enterprise ready, we're part of when we're building out new technology, we want to make sure that the customer's data can be trusted to stay within their projects. So when we're doing customization for things like glossary or importing training data to AutoML translation and or adaptive translation, you can have assurance that this is going to stay within your GCS, within your Google Cloud project, and is not going to be used for Google's model training. That's just part of how we have our terms of service set up with Google Cloud. The overall architecture for translation API AI, you can think of it in a set of layers. At the bottom, we have the overall Vertex infrastructure, things like our TPU, GPU, et cetera. And then on top of this, we have our model layer. So part of what my team specifically invests in is developing machine learning models specifically for linguistic translation. Our pre-trained translation models, which is also known as NMT, it's the classical neuromachine translation. Those support 135 plus languages. It is our most longstanding model. It is very fast. So it provides like a great preset to start with. Where its primary limits are is that it's not extremely flexible. So what the translations are out of the box, they are what you get, but they are very easy to develop with. We also have our custom translation models, which is AutoML. And this is where customers come in and they can bring their own training data, do customization with it. And these models were dedicated to you. They live in your project. They perform best for domain adaptation. It's specifically for things like healthcare or finance, where you need to get into a lot of terminology and company-specific terms that you want to have fitting that context. Our newest offering, which is what we'll be talking about here today, is adaptive translation and our translation large language model. So over the last several months, our team has been working. We're taking the best of our training data for our translation use cases that we use to build the classic translation models, but we're applying it to fine-tuning and upgrading our foundation LLMs. So general purpose large language models, taking those to make them perform well for this use case in particular, and combining that at the API layer to take in light level of customer data examples so that large language model can adjust to that context for what you would like your translation output to be. So we'll be talking about that. We have the Translation API Basic, which is our most pre-built, easy to use, easy to integrate with API, good for turnkey mobile applications on user-generated content. And then we also have Translation API Advanced. This is where you would come to do all of your customization, to consume anything that you build custom with a custom model or with our glossary for terminology control. It also has formatted document support as well as batch translation support, which is where you would do long-running operations with Google Cloud GCS buckets. So our overall intention is that we continually advance our translation quality and the base models. So for the pre-trained models, which are classic translation models, we are continuing to update those. They actually had advancements in the overall quality and handling for German, Japanese, Hindi, and Chinese just in April of this year. In this case, we took some of these advancements by going from single sentence translation to multi-sentence translation. And that includes that improves the overall fluency because there's more information that is being sent to the model that can help retain information across more than just a single sentence. So if you have information that is dependent, cross-dependent, for example, genders in a gender ambiguous to gender specific language, that will be better performing in these cases because more of that context is being passed to the model. This is resulting in a significant error reduction, according to our internal MQM studies. And MQM is a great way to do specific error assessments. So we see some real gains in that case. And so taking from this, one of the other areas that we want to continue to advance is making these more flexible in real time for customers without having to do full fine tuning. And so large language models are the technology advancement that really fits well into that case. And so that's why we're investing in fine tuning translation specific large language model to apply for customers on our API. And one of the other things to keep in mind when deciding between using large language model that's either general purpose or specific versus a classic translation model, there still is a latency difference between the two. So if you're, and it can be significant when you're doing very large volumes of content, because it takes longer to do all of that throughput, but also for real-time on-demand translation that might show up in like a real-time chat case or something else where a user is just doing a click to translate scenario. So these are the part of the inputs for determining when to use a large language model versus a machine, like a classical translation model. So our newest feature that Smartling will talk about a little bit in their assessment, their case study after me, is called adaptive translation. It is a feature that is an integrated API feature specifically designed to work with large language models. Right now, it is automatically paired with our translation large language model that we fine-tuned for this fit for purpose. But the adaptive translation feature basically looks to do a lightweight customization in real time based off of a data set that you import. And so the process is that you import a set of sentences. It can be anywhere from 5 to 30,000 examples. And our algorithm in the API will look at those examples and basically do a distance assessment to find the best fit to the other piece of information that you provide when you do the request, which is the source content that you want to translate. So if I want to come in and translate something like, welcome everyone, we're excited to have you join us today into Spanish, and I have a lot of other training data that kind of is in my specific voice and specific style, I can import that to adaptive translation as my reference data set. And then when I translate this content, it'll reflect more of what my desired fluent translation would be over like the classical translation. It does depend on like how different your content is from the base models, what kind of changes you would see. But that's essentially what the intention of adaptive translation is. And so the other thing that we launched, because large language models are out there and there's a lot of model choices now, we want to have a playground where customers can come in and test and try out and see the differences between model performance and model quality, and like see the kind of just real time how it fits for your particular translations. So if you come into the Vertex AI ecosystem, you can actually try that in a nice and friendly user interface in the same place where you have other prompting abilities for other use cases. So I'm just going to switch to here, and you guys can see what this looks like. So you basically would come into AI Studio, go to the language view, and you can also click from the card, go into the translate text card. And once you're in here, this is what the UI for the text, for the translation tasks looks like. You can see that there's a whole selection of models. And then these are some samples that you can just do a really quick translation with in a given language. And for the language support, you do the language selection. And then here is a French example going into English. It's a international relations text. And you can see here that one of the differences in the base translation model, there's a little bit of awkwardness in this sentence. And then it's also doing some different word choice here for going well beyond the bilateral framework to increasingly take on global influence. And so if I switch now to the Gemini model, you can kind of see a similar comparison. You have the temperature, output, different parameters you can select. And in this case, the wording is more of extending far beyond the bilateral scope and exerting increasingly global influence. So some different word choices. And then this awkward sentence down here seems to be resolved. And I think this is because the larger context window for Gemini in this case is handling the translation. And then if I go to the translation large language model, which is the one that we've custom built, you can see the good wording of this highlighted sentence for increasingly assuming global influence. And then also the fix in having a more continuous sentence. It's not breaking the sentence in the second scenario. And that's because our translation large language model is also taking in the multi-sentence context. So it is paragraph level translation for all of the languages that we support, and that should enhance the overall quality of the translation. And so overall, just to summarize, because the translation options out there for customers can be wide and varied, even within the same company, they have a lot of different needs. And so that's why we want to offer the widest amount of offerings on Vertex AI for ensuring that you can scale, meet your right price point and your right cost, and kind of get to the level of quality and granularity that you choose to customize with. Additionally, we like to work with partners. So a lot of integrations are necessary for kind of handling as many of your use cases as possible or having human review. And so we have offerings like Lilt and Smartling that are coming into marketplace. Lilt is already there. And if our APIs are not enough of the solution and UI that you're looking for, sometimes looking at some of these other offerings that we have integrations with are a great path. And a lot of the times it's also based off of a cost ROI ratio. We understand that. And so you have a wide range of choices for assessing your use case that will drive your quality and fit your best ROI. So before I pass it to Smartling, one of the things that I would suggest thinking about and working in localization is that a lot of times people ask the question of like, should I work with custom translation, machine translation, that's traditional, or foundation models? Like what's the best approach here? And what we're seeing in the industry is taking things in combination is where often you find a great ROI. So taking your base classic translation models or custom models, you can get those to scale up. They are low latency. They are very stable. And then you can look at the foundation models for other parts of the translation workflow, whether that be post editing or refining the content, because they can take a lot of the instruction tuning. That's where we are seeing the industry move, as well as some really helpful benefits of taking that approach. So with that, we have a number of resources listed here. We do also have a blog that is out that we'll drop the link to it into the chat. And you can go there to take a look at some more information on what we've gone through today. But I will hand it to Olga and Alex at Smartling. You can take it from here.
Thank you so much, Sarah. Thanks a lot for having us. I think we should start by introducing ourselves. So my name is Olga Brigava, and I'm a Vice President of AI here at Smartling, leading our machine translation and AI efforts. And I pass it on over to Alex.
And I'm Alex Januszewski. I'm Senior Director of MT and AI Solutions. So I look after a team that trains, maintains, and scores MT engines.
Great. So first, I want to open up with Smartling vision on where language AI actually fits into the global content delivery ecosystem. And then we'll move on to where Google models actually are a great fit and are used in that ecosystem. We'll touch on that later. So basically, if you look at AI throughout the global content transformation journey, there is a good home for AI pretty much on every step. First, you analyze the source content and eventually also transform the source content, making it more adaptable for automated translation. Then there is customization, which Alex will talk about a little bit more, and which Sarah already spoke about quite a bit, and also foundational model fine tuning. So all of this is pre-translation steps. It's very important to have clean data. Again, as was mentioned earlier, super important to have clean data for model fine tuning or for machine translation, engine customization. So that's your pre-training step. And again, this is where foundational models play a role, and also data cleanup. Then we move on to the automated translation step, which is the core of this conversation and this presentation, where you can have custom MT engines or adapted MT engines, or actually also use large language model as a translation provider, and also AI powered translation memory. And that's another area that I will touch on a little bit later. And then you have APE, right? You can get the best of both worlds. You can get the accuracy and adequacy of machine translation. Now, also, was very pleased to hear that it's now augmented with context, providing additional fluency and accuracy, and combine it with features that are best addressed through large language models, such as glossary replacement and also stylistic preferences, formalities, and so on and so forth. Another important area is workflow decision step, where you use AI. And again, Sarah mentioned MQM. That's the best way to automatically measure what you do with the content next after it has been translated. Do you just push it through to publishing? Does the translator know that they only need to look at it a little bit and scan through it? Or does it actually require the full human in the loop effort? So that's the ecosystem in a nutshell. And I think it goes over to Alex from here.
Yeah, so I'm going to talk about our experiment, our case study with Google Adaptive Translation. Right. So essentially, we took two verticals. One domain was financial. The other one was tourism and hospitality. We ran an average of 6 languages for one vertical, 3 languages for one vertical, 9, so 6 if we average them, and we compared 2 models. So ultimately, we had 24 scoring runs that we compared. So our success criteria was, if we use textual auto scoring, and I'll show you what that is in a moment, does Google Adaptive outperform other Google models, right? Why are we using textual auto scoring? Because to have a linguist, a human being, sit down and analyze 9 different languages and 2,000 sentences per language is going to take quite a long time, right? So textual scoring allows us to do this in a very efficient manner. So what are the a quick primer on textual auto scoring? Primarily, we're looking at 2 metrics. One is called edit rate. The idea here is very commonsensical. The less I edit as a linguist, right, the lower the number, the better, because that means I'm editing less, I can be more productive. Another metric is called BLUE, which stands for Bilingual Evaluation Understudy. Here, the idea is, I have my text from machine translation, and I have a reference translation, a human translated text. The closer they are to each other, the less I have to edit, the more they're alike. And this is on a scale from 0 to 100, where the higher it is, the better. And you see a nice color coding here from red to yellow to green, right? So let's take a look at a real example. So here's our source string in English. We have our human translation in the middle in Portuguese, in Brazilian Portuguese, and we have our customized machine translation, right? And what you'll notice is in the human translation, the only difference is the last word, which has 2 characters added, right? Now we can compute that, and our edit rate here, when we're talking about the number of characters I have to change, is only 2%, right? So if I'm a linguist and I'm faced with this customized machine translation, it's basically almost perfect to start out with, and the number of edits I have to do is very, very little. So these are the metrics that we used when we were evaluating Google Adaptive Translation. So our results, all On vertical 1, where we had 9 languages, Google Adaptive won 6 out of the 9 using this textual auto scoring. On vertical number 2, which was tourism and hospitality, Google Adaptive won 2 out of the 3 languages. The other thing that was very compelling for us is that we saw an up to 23% increase in quality over the generic Google Translate models. So the takeaways. The only way to customize an MT engine using LLM technology, if you don't have a lot of data in sparse data scenarios, is Google Adaptive. Google Adaptive is eminently well suited for creative content. So if you think of things like marketing, for example, it's very, very good for that. And the last point is price. So we see that Google Adaptive is up to 2 times cheaper than other competitors for dynamic machine translation. So I'll turn it over to Olga now to kind of talk about Google Adaptive as part of our overall strategy.
Yeah. So as Alex already outlined, and as I alluded to earlier, Google Adaptive comes in super handy when we don't have much training data, yet we want the best translation outcome. So in the ecosystem of other AI solutions or natural language processing solutions, large language models, and machine translation, it definitely plays a role and will continue playing a role as a overall as a part of our overall platform. So next slide, please. Yeah, and we will also talk a little bit about other Google AI offerings and other Google models that are actually used in our tech stack and in our ecosystem. And I will touch a little bit on other solutions or other features that we have in the platform where we're using Palm, where we're using Gemini, and whatever the future models are going to be. So altogether, if you look at their entire tech stack, we see very, very strong use case for Google Adaptive application. So let's go. Yep. And especially when you look again, Sarah spoke about the ROI and making sure that you are making the best investment and get the best ROI for your money. Obviously, with a highly competitive price of just $25 for million characters, it's a very attractive, customizable solution for Smartling. Some of our customers would come in with no training data, and that's where we would use other applications, such as inserting glossary term over a generic Google model. But when we have any training data, then obviously that's the optimal way for us to use fine-tuned models in our translation process. Next slide, please. Okay, so one other area of application of a Google model, in this case, that would be Palm, in fuzzy match repair. What is fuzzy match? Right, fuzzy match is a localization concept of being able to leverage and reuse previously translated content, which is being stored in the TMX translation memory exchange format in the platform. Now, when you have the new source that is drifting away from the previous source, the further away the source is, the lower your leverage of your previous content is. So where we're using Google models is if you have a source text that is drifting from, here we just have one word, right? We have chat instead of photo. That's drifting away from the previous source. We actually elevate this fuzzy match and bring it closer, elevate this fuzzy match and bring the target close to the new source. So subsequently, your leverage of your previous content significantly goes up. So that's one application of Google Palm model in our platform. And let's go over to the next slide. One other thing I forgot to mention, that when we do this, we don't just brute force the changes, but also inject them in morphologically aware manner. So the fluency of the sentence is not broken. And it's essential, obviously, we'll go back to the days of regular expressions or current applications of more brute force solutions. Obviously, that's a major step forward. So as you can see, we do have a top performer in this case. That would be Chat Bison model, Chat Bison model. But when we look at the cost performance, again, we see that three fuzzy matches, Chat Bison model is equally most cost attractive way of using this functionality. So
I think it's the Gemini model, right?
Yeah.
Gemini, yeah.
Yes. so let's move on to the next slide. And as you can see, after we've applied fuzzy match repair, HTER is a metric that measures edit distance. You can see that actually percentage of strings that do not require any edits increases more than twofold. So again, there is pre-application of Google Model, and then there is post-application of Google Model. So as you can see, it has significant impact on our customers' ROI and ability to reuse privilege, to leverage previous content. Okay, next slide, please. Go ahead, Alex.
So yeah, so I'll take this slide. So Olga was mentioning that we're using Google's various foundational models for tasks to smooth out or correct machine translation output. And she was talking about fuzzy match repair. Another task that we're doing is formality conversion, right? So here, imagine you have content, let's say from a bank like Bank of America, TD Bank, Wells Fargo, as opposed to content from a company like Disney, right? The tone, the corporate brand, the style is going to be very, very different, right? If you're Disney and you're trying to attract families to go on a cruise ship, you're going to want a more casual, a less informal tone. And one of the ways that we're using Google's foundational models is basically to convert a formality conversion from formal to informal. Now, the tricky thing here is it's not just a matter of converting from a formal U to an informal U. You want to make sure that it's grammatically correct when you do the conversion. So you want proper conjugations of all affected verbs, adjectives, nouns. And the other tricky thing that Google's foundational model does very well is it doesn't change the tone. It only changes the word choices to make it informal, right? So it doesn't make it too overtly informal. And we've benchmarked this on 4 different languages. For example, for Spanish, which is our best performing language using Google's foundational models, we see a successful conversion 95% of the time. And even for the weakest language, which is French, we see an 80% successful conversion. So for us, this is a tremendous, tremendous help, because otherwise it would be using a linguist whom it would take a colossal number of hours to do this manually, right? So now they're basically just vetting that the LLM has actually done its job properly. So now that we've spoken about different use cases, I'm going to turn it over to Olga to close and kind of explain how all of this comes together in Smartling.
Yeah. So basically, again, talking about the Google Adaptive solution, I already mentioned that we have customers who are just embarking on their localization journey. And those customers, again, will benefit greatly as we've been able to accumulate some of the content. They will benefit greatly from that customized solution. Then we have entering new markets, right? If a company does not have much parallel training data for customizing models for new markets, then again, if a company decides to branch out into new geos, then again, that's a fantastic use case for us. And then if there is a significant content drift, then again, it's reasonably hard to build up huge training corpora when your content changes tremendously, when, for instance, you've injected a new product or pivoted in your marketing message. So again, capturing significant content drift is a great use case. Another thing I wanted to mention, that we're very happy to be working very closely with the Google team, and obviously the models evolve. And we make sure, and Alex's team and another team within Smartling, we make sure that we follow the model evolution trajectory. Right, like right now we are, Alex and team are testing Gemini Flash 1.5, and generally we don't just, if we see that the next generation of the model is outperforming what we had before, then we have a mechanism of implementing that model and pivoting fast. So I think that would be it from us, right, Alex?
Yes.
Great. Thank you both. So I think that there's some links here for the Google Cloud community. If you haven't been part of that in the past, this is also where we'll come back to for answering any questions we don't get to in this session. And there's some things in the coming schedule for that too. So it looks like there are a couple of questions in the chat. We can take them here, and then any other follow-ups we can do back in the community after this session. So this one, going back to my comments of when I was referring to automatic post editing, that's not something that's applied natively in our API yet today. Automatic post editing tends to show up in translation management systems like Smartling or others. Olga, did you want to mention like kind of how you guys think of this space, whether it's an entire area? Is that related to the fuzzy matches?
Well, fuzzy matches happen pre-translation, right? That's one of the areas. However, I also mentioned glossary term application, morphologically aware glossary term application, and that's a great example of automated post editing, where the translation itself has already been completed. In this case, and we predominantly use Google models for that, and then you apply the glossary using, in this case, that would be Palm, apply glossary after the translation has been completed. Now, I don't know, Alex, if you would agree with me, I would say that referencing an external glossary is a form of a RAG, right? I mean, it can be loosely described as a form of a RAG, right? Because you do go to an external source. So, Monica, to answer your question, I would actually define it, because you do reference external linguistic assets. I would classify it as RAG. Now, Alex, you also spoke about formality and stylistic changes. Again, it's happening post-translation, after the translation has already been completed by, in this case, again, by a Google model. And again, the same, basically, there are external style guides. And Alex, I don't know if you want to touch more on that.
No, that's exactly. I would define both examples as RAG, because what we're doing is we're looking at an external resource like a style guide, or looking at a glossary, using that to form a prompt that's sent to, with a few shot examples, that's being sent to the Google foundational model, and that actually smooths out or corrects the empty output.
Right. So in this case, this is what's happening within the Smartling software and their offering. That is what they're presenting the learnings on. It is not native in the cloud APIs. You can build some things with RAG and with foundation models. That's not what we covered here with the Vertex APIs. But for the translation use cases, a lot of the TMSs kind of solve that area with you. TMS is being translation management systems, if you're not familiar with that. So I think that wraps us up. There is another question about GitHub repo. We'll share that link in the community, because we don't have it handy at the moment. We definitely have sample code available both in our Google Cloud Docs, and I think some things along those lines are published. Yes. So there was an additional question that came up on latency. So the best thing I would say here is to go back to this graphic. This was done by another third party, Intento, kind of looking at a general assessment of overall latency. So there's not hard numbers in here, but generally the classic translation models that you see down are basically all grouped down here. The foundation, which is basically large language models, general purpose large language models, right now, because they're both large and taking in large volumes of content a lot of the time, the size of the models and the performance of the models right now is just not as fast as the more efficient machine translation models. And this is a logarithmic scale. So while this doesn't represent some of the extra small models in here yet, so things like Flash or what you might have for on-device, right now there is an order of magnitude difference between them in terms of doing real-time translation. So that is something to keep in mind as you're doing rollouts for throughput.
We found, just to add to that as well, we found a similar thing in our studies as well, right? When we were presenting Google Adaptive, it performed quite well, right? And you could, as I said, it won in a lot of cases, but it was slower, at basically 5-7 times slower than if we were running Google Translate, right? And that's kind of expected behavior at the moment. It's going to get a lot better.
We are working on improving that as well. And I think the foundation models will improve slowly over time. It's a question of whether this is a pretty large gap to close. Machine translation is very fast. I think we'll see where that progresses in the industry. For now, this is one of the trade-offs. Great. So there's a link here to the Google Cloud Events community. You can take a look at more detail there. And if you're catching up on this on demand after the fact, please do go and check out the cloud events. And you can post additional questions likely in discussion there as well. Willie, anything else to wrap it up?
That's it. Thank you, Sarah, Olga, and Alex. Action-packed session. Like Sarah said, please feel free to ask questions in the community. We put the link in the chat. Continue the conversation. You can help answer questions. You can ask questions, but we'd love to hear more. And with that, we'll end today's session. And thanks for everyone joining.
Thank you.
Bye-bye.
Thank you for having us.